Hi guys, and welcome back to my channel. This would be the third tutorial for making an ethical rat. We have created the ethical injector, which basically behaves like a general packer. It is creating a new section inside the P file and is going to add, it is able to add a file, inside that last created section. So now we don't focus with this anymore. We just have the fun DLL. So this DLL basically will have the all the features and socket communication part. And I have created a new project called load.me. This would be the loader, so it will have just one role. We're gonna use the injector to inject inside the loader this DLL, so the loader will have the DLL inside, and its only role will be when we double click on it, it's going to output from the last section the payload, the DLL, onto the system, and then it will call run dll32.exe to actually execute it, and from there we're gonna set up persistence so it can run with the Windows at Windows startup. Okay, so let's get started. Right click on the solution, add new project, add a C++ empty project. Just create here a right click on the source file and new item, new CPP file. I just named it loader.cpp, and make sure you have the following properties both in release mode and also in debug mode. Okay, so we need to run also on Windows XP to be able to. Unicode character set, we can optimize the whole program. Then in C++ in general, we turn off all warnings. We're gonna use here a program database Z optimization. Preprocessors, we just going to add only this here. We're gonna let to inherit from parent or project defaults. Then code generation, we leave it multi-threaded. We disable security checks, and we're not gonna use a function level linking. Then in linker, in input, in general, make sure you disable the increment linking. In input, you can just set the kernel 32 library and user 32 library. Then in system, make sure it's Windows system, and I think that would be all. So in release mode and debug mode should be the same. Okay, so we're gonna use two type of entry points, for one for debug and one for release. So since we are in debug mode, but hold on, just let us include first the Windows H library. Okay, when we are in debug mode, we're gonna use the following entry point: winmain and h module current, h module previous, lpstr cmd int show. Okay, just let me put this aside. So this is the entry point we're gonna use in debug mode. Okay, and let me just show you a difference. So since we are in debug mode and we're using this entry point, if I'm gonna right click and rebuild this project, and we're gonna go and open it, so keep in mind this is in debug mode. So we go into debug, you see that the load.me has 280 kilobytes, but when we build it in release mode, we cannot use this, we won't use this, because if we build it like this and now we go into the release folder, you're gonna realize that the load.me has 71 kilobytes. But we can actually define our own entry point definition, and it's gonna reduce the size a lot. So let me show you. Instead of this, we just going to use a simple file, load entry, let's say. We're just gonna call it like this, and we're gonna set up a pragma comment for the linker. and we're gonna specify that the entry is going to be this load entry. Okay, so now in release mode, if we build a project, it's gonna do the same thing, but if we go to the release folder, you realize it has now 3 kilobytes. So this is what we're gonna use in release mode. But for now, for the debug mode, we're just gonna use this definition. So we will start from the following scenario. Now the loader will have inside its last section this DLL file. So at runtime, it will dump the last section and save the file onto the system. For this to work, we need first to create a function which will get the image base from this loader, and then we will need to create another function which will locate inside this loader the actual part where the DLL is located. So I'm going to create a new CPP file and a new header file. So I'm just gonna call the header file first. I'm just gonna create it and I'm gonna call it tools.h, and then I'm gonna create a CPP file. Just gonna rename it tools.cpp. Okay, so in tools.h, I'm just gonna create a namespace. I'm gonna call it tools, and here create a definition, get image base. It's not finding the pvoid because we need to use Windows H here, but instead of that I'm just gonna create another header file. I'm just gonna name this I don't know, includes.h, and I'm gonna include here everything. So include windows.h, and we also going to include tools.h. So now we go back and it should be okay. Okay, so this is the function that we will going to create. So we go back in tools.cpp, and here we just gonna include the includes. Okay, and since the namespace is tools, we just going to create this function, get image base. This is a pvoid type. We will use assembly, so it will be a pd word. The virtual address is gonna be a pd word. We're gonna typecast it to the same variable type, and we will difference this actual function name here. Okay, and then another pd word, this will be the image base, which will leave it as null right now. Okay, I cannot type. Alright, so now we're gonna write some assembly code. We move virtual address into EAX. We're gonna just create, we're gonna here create an iteration. Let's just call it because we need to check here for MZ, and then we're gonna end here the iteration. I'm gonna create here a sub, So this is just 1000, yes, because it's from right to left. And iteration here, and we're gonna move into image base AX. Get out from the assembly, and here we're just going to return the image base. So using this function we can get now the image base, which means in loader we're gonna call it like this. So we're gonna make here a pbyte module base. This is a pbyte from tools. The get image base function will be called. We're just gonna include here includes.h. So we have the module base. Then if this module base is not equal with an error, then we will extract the payload from section, and then we will move the payload onto, let's say, AppData. Okay, instead of when I say payload, I mean the DLL in our case. Okay, so in order to do these two things, since we get the module base of the current process, which is the loader, we need to create a function that extracts the DLL from the last section, and then we're going to move the payload onto AppData, maybe with some random generated name. Okay, alright, so for this we will create in tools.cpp another function. Just let me go to loader.tools.h and declare here, make here the definition. So it's gonna be a pbyte extract DLL file, let's say, and we need here a pbyte of the module base where from, and then a pd word of the module size. It's important. Okay, so we're gonna grab this, put it here, and I am just going to write here tools. Okay, and before writing this function, I'm just gonna go back here and gonna do the following. So we have the module base and the module size as parameters, which means we're gonna declare here a dword module size. First will be null, then a pbyte, let's say DLL memory is going to be equal with tools extract DLL file from the module base, which we declared above, and difference inside the module size. Okay, we're gonna do it like this. So inside the DLL memory we'll have the extracted DLL file into a pbyte. Okay, so right now we're gonna write this function. So in order to write this function we need to remember the first tutorial. So pimage dos header, image dos header is gonna be equal with the module base typecasted to this. So now we are inside the DOS header of the module base, and if this is a valid PE file, so remember, if the eMagic is equal with image DOS signature, which is the 0x5A4D, then we get into the pimage NT headers, image NT headers, again typecast it to this, it's going to be equal with the following. So always the empty headers are the module base plus the image DOS header, the ELFA new, if you remember. Okay, now we need to make sure that the empty signature is valid. So if image empty headers signature, it is a image empty signature, that means we can get to the last section. So the first section, the image section header, first section will be equal with something. The first section will be image first section of this image empty headers. So this is the first section, and now we need to get to the last section, so that would be the DLL section. So p image section header DLL section will be with typecast again, and will be the first section plus the number of sections. The number of sections you can find it in empty headers inside file header dot number of sections. Okay, like this. And since now we are in the last section where the DLL is located, if this doesn't give us an error, we just gonna return into the module size the DLL section. We need the virtual size, so the virtual size can be found in MISC virtual size, and here we're gonna return the actual virtual address from this module base, but we need some kind of offset to pointer. So for that we're gonna create a definition. I'm just gonna do this in tools.h. So outside of namespace, define RTL offset to pointer. It's gonna get two parameters, the module and the pointer, and it's going to return as p byte the p byte of module plus as d word the pointer. This should so the definition should look like this, and inside tools.cpp, since this is a p byte, we can just return that RTL offset to pointer. So return RTL offset to pointer. So we need the module base here and the virtual address. So virtual address is inside the DLL section, virtual address. This is how we get out the DLL from the last section. Okay, now we go back to the loader. Since we have the module base of the current image here, then the DLL memory p byte now has the DLL from the last section. We just need to move this DLL inside AppData. We just gonna use create file w. Okay, so we use the bytes written, we're gonna store it here, then into a vchar the AppData path, it's gonna be the size of this array as max path. Then if something, then we do the following. So we're gonna get the AppData environment string using expand string w. So we're gonna typecast it as text environment string, AppData in between percentage mark, then inside AppData path max path -1 for the null byte, and if this is greater than 0, which should be okay, then we're gonna add to the AppData. So right now the AppData contains the whole path of our AppData path from the system, and now we need to add to it a slash and DLL name. So we just gonna use get tick count for generating a random some random numbers for the name. So to append this random name to the app data, we're gonna use vsprintfw inside app data path. Okay, and here we're gonna have some string format. So we're gonna do it like this. The first will be a string, then lu dot, then cl percentage mark, and then a c. The first one will be the app data path itself. Then here we're gonna just get the tick count, get tick count. Here we're gonna replace it with d, and here we're gonna replace it with l. So instead of just writing here random number and then random number, so this will be the whole app data path. This will be some random number dot, and here dot dll, but this will be replaced with d, then we keep an l here, and this one will be replaced with the l. Okay, after we finished, we need to create a file handle. So handle new file, create file w. So AppData generic write 0 null create always, then file attribute normal, template just null. Okay, so if this new file is not invalid handle value, then we can just write the file. So write file, this new file, the buffer will be the DLL memory, the size will be the module size, and then bytes written, we're just gonna store them here, as I said, difference, the bytes written, and the last one, the overlap, we don't care, so that's gonna be null. Okay, so let's just test this out. We're gonna leave it in debug. I'm just gonna rebuild the load me. Okay, no errors. So I'm just gonna set, as you can see, this is the name is being written with bold because it's the startup project. So I'm just gonna make this one the startup project. Okay, so right now I rebuild it in debug. We go to open in File Explorer, we go into debug, and we can see that load me has no section inside which contains the DLL. Yeah, so the last one is the relog section. Okay, so we're gonna use the ethical injector to actually inject our DLL inside the loader. Okay, I just noticed that in tools.cpp here in the extract DLL file function, we actually need to do file header the number of sections -1. This is how we get the number of sections. Okay. Alright, so now we're just gonna test it. So if we go to open the folder in File Explorer, this is in debug, so we go in debug, we realize that loadme has 281 kilobytes, so it doesn't have any DLL inside. The last section is .relog, okay, which is not even a PE file. It doesn't start with MZ. So we're gonna use the ethical injector to inject inside the loader this DLL. So right click with shift. So we're gonna do the following: ethical injector.exe, the section name as we declared in the previous tutorial, I don't know, .test, then the target file, the target will be loadme.exe, and the actual file that we inject will be fundll.dll. Okay, so notice it has 281 kilobytes, and if we inject now, the DLL has 1111 kilobytes. So right now inside this loader, the DLL exists in the last section. So if I right click and open with CFF Explorer, in the last section there is this test, and here you can see the DLL. So it starts with an MZ, which means that's a valid DLL. Also here is the some stub information. So now, because we have written in loader.cpp the following function, it should get the image base of the current loader. Then we're gonna extract the DLL from the last section inside we're gonna store it in DLL memory pbyte, and then we're gonna write this with a random name in AppData. So now it has the DLL inside, and if we run this program, you notice it closed itself. But if we go back to AppData, you realize that in AppData roaming there is a file created with a random name .dll with 832 kilobytes. But we can check if this is indeed the right DLL by calling the run-dll32 executable. So we leave this here where it has outputted in the roaming. So we're gonna go and run the DLL32. So run dll32.exe, and we're gonna run the DLL from this path. And we need the entry name. I believe we called it fun entry, and if I hit enter, indeed is the right DLL. This is the code that the DLL has inside. Yeah, so we have successfully added into the loader the DLL, and we have successfully outputted from the last section the DLL on the system. So in the next video we will gonna call here the run DLL32 using create process internal, and we're gonna delete the loader and also set up the persistent as I said. So don't forget to give a thumbs up and to like this video. Bye.